Okay. So what are you learning today? Today you're learning about radioactive decay. When the atoms are gonna start like going through a nuclear decay when you have unstable isotope. One more time. What are isotopes? Do you have the answer to that question? What are isotopes? No, silent treatment. They are atoms of the same element with different number of neutrons. For example, and I'm using this example because it's a heavy element and ones that you know very well. Uranium. Let me write this over here. Uranium. If you look in the periodic table, the atomic number for uranium is 92. 92. Let's say that I have uranium 238. Remember that this number over here is giving me the number of protons. And this number over here is giving me the mass number. Mass number. Mass number is the number of protons plus what? Silent trick. See, the mass number is the number of protons plus the mass of the protons. Are you looking at the mass defect? I'm talking about the mass number plus the number of neutrons. Okay? That's the number that I have over here. The number that I have over here is the mass number. So if the mass number is 238 and I have 92 protons, how many neutrons do I have here in uranium 238? Do the math. How many do I have? No, Miss Ramos. You subtract. See, remember that you are looking for the number of neutrons. You have an equation, and that way you're going to find the number of neutrons. Okay, Miss Ramos, but I have a lot of neutrons in that nucleus in an unstable one. See, in an unstable uranium atom, if I have 92 protons, I should have 92 neutrons. Is that the case? Is that the case? Do I have 92? No. How many more do I have? How many more? I have like 54 more neutrons. Miss Ramos, how do you find that number? 146 minus 92, then you got the 54. Miss Ramos, what's going to happen when you have this many neutrons, like extra neutrons in the nucleus? The tendency of the atom is to reach stability. And what is bringing stability to the nucleus? Same amount of protons and same amount of neutrons. Oh, Miss Ramos, how do they get rid of the extra neutrons? The answer is radioactive decay. Do you understand that part? What is going to happen during radioactive decay? We have three types of radioactive decay. The first one is alpha decay. What happened during an alpha decay? What happened during an alpha decay? And that's why you're explaining this. Miss Ramos, during an alpha decay, an alpha particle is released. Miss Ramos, what is an alpha particle? An alpha particle, okay, by the way, you can use that letter. This is the Greek letter for alpha. Is a helium nucleus. Helium nucleus. And if you look in the periodic table, the symbol for helium is He. Helium nucleus, meaning that I'm going to have inside that nucleus 2 protons. Inside that nucleus, I'm going to have 2 neutrons. So when I add the 2 protons and the 2 neutrons, I have 4 over here. Do I have the electron if I have only the nucleus? No. That's why the charge of this alpha particle is 2 positive. It's not neutral because it doesn't have the electron, because an alpha particle is a helium nucleus. Protons and neutrons, no electrons. Questions until now? If you don't have questions about this, you're not going to understand the nuclear equations. Questions about alpha particle. This is an alpha particle. It can be written using this notation or the Greek letter alpha. Questions until now? No? Okay, I love this. No questions. Because I'm going to use all of this against you. Okay. So alpha decay. Okay, I have uranium. I'm going to use the same example. Uranium 92. Uranium 238. Uranium 238. You know that this over here is atomic number, and over here you have the mass number. In order to reach stability, uranium has to get rid of 54 extra neutrons. How? By emitting alpha particle or going through radioactive decay. So my unstable nucleus is gonna emit the first alpha particle. Okay? Meaning that now I don't have in my nucleus 2 protons. So the atomic number is going to be reduced by 2 because 2 of the extra protons, together with the neutrons that were leaving the atom, I have 2 protons that were leaving the nucleus too. So consequently, the atomic number went down by 2. If the atomic number changed, do I have the same element? No. What is the element that has an atomic number equal to 90? We don't know, Ms. Ramos, because we don't have a periodic tables. Thorium, atomic number equal to 90. If together with the 2 protons, 2 neutrons were leaving the nucleus, what's going to happen to the mass number? It's going to decrease by 4. 234. Ms. Ramos, is that possible that a new element, after the radioactive decay, new elements are going to be formed? Yes. Yes. Uranium, after 1 alpha decay, because this is an alpha particle, after 1 alpha decay, uranium 238 becomes thorium 234. Is thorium 234 stable? They're not answering me. Is thorium stable? They don't know. Okay. Do you have the same amount of neutrons and protons inside the thorium nucleus? Do you have that there? They don't know that. They don't want to learn. No. The answer is no, because the mass number is not equal to twice the atomic number, meaning that I was supposed to have a 180 as a mass number, but now I have 234. So I have a lot of extra neutron in the thorium nucleus. What's going to happen, Ms. Ramos? The process is going to continue. Because remember, the goal of the nucleus is to reach stability. What happened to the atomic number? Since 2 protons were leaving the nucleus, it's gonna decrease by 2. If I have an atomic number equal to 88, do I have the same element? They don't want to talk to me. Okay, what is the only element in the periodic table that have an atomic number equal to 88? They don't have a periodic table, Ms. Ramos. Radio. What's gonna happen to the mass number, Ms. Ramos? Okay, since 2 protons and 2 neutrons that were leaving the nucleus, now the mass number is gonna decrease by 4, 230. Ms. Ramos, is radium 230 stable?
No.
No. So what's gonna happen? It's going to continue. The process is going to continue until you have inside the nucleus same amount of neutrons, same amount of protons. Do you understand what I'm trying to say? We don't care, Ms. Ramos. So, Ms. Ramos, after 2 alpha decays, see, after uranium 238 underwent 2 alpha decay, what was the new element form?
Radon.
230. Understand that? No, Ms. Ramos, we don't care about that. Okay. Good to know. Okay. Let me use another example. Okay, let me get over here. I'm making this up. Iodine. Iodine has an atomic number equal to 53. 131. Yeah, I'm using this one because this is the one that they used to treat cancer here at the hospital. If you have a parent or you have a relative that has like thyroidal cancer, they're using this isotope to get rid of the bad cells. And when your relatives, they are receiving this treatment, you're gonna get close to them because you're gonna be receiving the radiation from the isotope that they're using. Iodine 131. Remember that the number over here is the atomic number, and this over here is, what is the number?
Mass number.
The mass number. Okay. 1, 2, 3, 4. So 3 minus 6, 3, 47, 47, 47, 47. 131 so for 12. Let me see. Okay, after alpha decay, iodine 131 becomes silver 119. How many alpha particles were released? How many alpha particles were released? 12. Wrong. That's wrong. How many alpha particles were released? And I'm recording this. See, they're not paying attention to what I'm saying. And I'm going to post this in YouTube. I'm going to post this on the stream. And I'm going to use this against them. Because I have noticed that when I'm assigning a unit, they are completing all the lesson without waiting for my instruction or without paying attention to a genuine instruction. And now they are getting F in the assignment. And when you put an F in the assignment on the grade book, the grade goes down by 20%. So I'm just recording all of this to cover my back. Because you know what's going to happen, right? They're going to blame me. They're going to blame the teacher because they don't know how to do this. How many alpha particles? What happened to the alpha decay? What is going to happen to the atomic number?
3 alpha particles were released.
How many?
3.
3 of them. How do you know that?
Because when you subtract 131 by 4 3 times, you get 119.
There you go. That's the reasoning. You can look at the atomic number. What happened to the atomic number? The atomic number went down by what? The atomic number went down by 6. Yes or no? And you know that in every alpha particle, you're going to have only 2 protons, meaning that 2 multiplied by 3, they're going to give you 6. So 3 alpha particles. And this is the type of problem that you can expect in a bell ringer activity. Okay, by the way, for the next class, you're going to have a bell ringer activity like the one that you had today. Questions about that? And this is alpha decay. During an alpha decay, alpha particles are released. What is an alpha particle, Ms. Ramos? It's a helium nucleus. You don't have the electrons in there, and that's why during this radiation, you are going to release, the nucleus is going to release energy. And that's what in Chernobyl, still, you cannot get close to the sarcophagus because a lot of alpha particles are released. And when those alpha particles, they are touching your body, they are interacting with your cells, producing mutation in your DNA because of the 2 positive over there. It's not an stable nucleus. It's not an stable atom. It's interacting with matter that is in your body. Questions about that? No? Okay, I'm going to continue. Beta decay. Miramos what's going to happen during a beta decay. During a beta decay, 1 neutron. You remember that I'm talking about unstable isotope. An unstable nucleus or unstable isotopes are nucleus in which you have a lot of neutrons, more neutrons than protons. When you have 2, 3, 4, 25, 50 extra neutrons in the nucleus become unstable. Okay, unstable. What is the behavior of the nucleus just to reach stability? How the nucleus is going to reach stability? By emitting radiation. It could be alpha, it could be beta. Okay, and what happened during beta decay? 1 neutron is transforming into a proton, and 1 electron with a lot of energy is released. And we call this a beta particle. That's beta or in the Greek alphabet. Okay? Mirama, we need an example. I'm going to give you an example. Carbon 14. How many neutrons do I have in that nucleus? How many? 8. How many extra neutrons?
2.
Yes. How the atom is going to react, or how the nucleus, because we're talking about the nucleus, how the nucleus is going to react to those 2 extra neutrons by emitting alpha decay. Mira qué lindo. Alisa Alonso and Cory Garcia, they resubmit at 9:02. 9:02. And Cory, you know that I'm taking picture of everything. There's resubmit the homework. Okay, so how the nucleus is going to react to the 2 extra neutrons by emitting a beta particle. And what is a beta particle, Ms. Ramos? It's an electron with a lot of energy. But during beta decay, what's going to happen to the atomic number? See, the extra neutron is going to become a proton. So the atomic number is going to increase by 1. Do I have the same element in there?
No.
No. And what is the only element that have an atomic number equal to 7?
Nitrogen.
Nitrogen. And this is simple math. See, 14 over here. You know that the mass number is equal to the number of protons plus the number of neutrons. Yes or no? So in carbon 14, I have 14 over here, proton 6 plus A to equal the 14. Yes or no? So one of these extra neutrons becomes a proton. And now I have 7. I have 7 protons. I'm going to have 7 neutrons. The mass number is going to change.
No.
No. When carbon 14 becomes nitrogen 14, is nitrogen stable?
Yep.
Yeah, there you go. So carbon 14 becomes nitrogen 14, see, by emitting an Evera particle. And what is Evera particle? An electron with a lot of energy. And what happened during beta decay? One of the extra neutrons becomes a proton, increasing the atomic number and releasing one electron with a lot of energy. Questions about that? No? Okay. Gamma radiation. Ms. Ramos, what is going to happen in gamma radiation? I don't know if that teachers that you have in Ingenuity was explaining that to you. But in gamma radiation, the only thing that is happening, I'm analyzing this in isolation. Gamma radiation is going to be accompanying the alpha and beta decay. During gamma radiation, nothing is happening. No new element is formed. Just a lot of energy is released in form of gamma rays. Now, are you going to be able to see gamma radiation by itself? No. Most of the time, what you see is an alpha decay accompanied by gamma rays. Super dangerous. Because, see, it doesn't have a mass. It's a bunch of photons that are bombarding your body in case that you are exposed. You're going to start see when you are exposed to gamma radiation together with the alpha decay, you're not going to become a superhero. You're not going to become the Hulk. No, you're not going to become a Spider-Man. You know what is going to happen to you? You're going to die slowly from the inside out. All your cells, they're going to start like bursting inside you. So you're going to be like, I don't know, bleeding from the inside. And it's very painful. Yes, you don't become a superhero when you're exposed to gamma radiation. Questions about this? You don't have any questions about this? You understand this very well? Okay, Ms. Ramos, you are talking about nuclear. You're talking about nuclear equations. When you're talking about nuclear equations, in nuclear equations, new elements are formed. Yes. Why new elements are formed? What's going to happen to the atomic number? The atomic number is changing. Okay? It's decreasing by 2 or it's increasing by 1 in case that you have the alpha or beta decay. That's how the universe was formed. By fission and fusion of different elements because of radioactivity. In nuclear equation, new elements are formed because the atomic number is changing. My Ramos, during a chemical reaction, are new elements formed? The answer is no. I'm going to give you an example of a chemical reaction. Let's say that you have iron solid reacting with the oxygen that is in the atmosphere just to produce iron trioxide. See, you have iron at the beginning as part of the reactant and you have oxygen at the beginning as part of the reactant, and in your product still you're going to have iron and oxygen. You don't have a new you don't have a new element forming in there. That's an example of a chemical reaction. So that's one of the main differences between a nuclear reaction and a chemical reaction. During a nuclear reactions, new elements are going to be formed. During a chemical reaction, no new element is going to be formed. Questions about that? No? Can I give you a quiz on this? Yes.